Hello everyone. In this video, we talk about object-oriented programming or OOP for machine learning and data science. Object-oriented programming is the backbone of many machine learning and deep learning libraries. And understanding OOP concepts empowers you to easily navigate and utilize these powerful tools, whether you're manipulating arrays in NumPy or building complex neural networks for image recognition. Think of OOP as the blueprint of a house. It provides a structured way to organize and understand how different components interact, just like rooms in a house. This understanding is crucial for modifying or extending the code base, debugging issues, and even creating your own custom models. To get us started, I would like to emphasize that we have two programming approaches or paradigms. The first one, which we are usually is our first choice, is procedure-oriented programming or POP. This is very much like when we do a statistical data analysis, meaning that we're gonna start with a step-by-step execution of procedures. For example, we import some data, we do some pre-processing, then we may find some statistics about data, and then print some results or plot some results. And in this case, you can think of the program that you have as a set of functions that perform specific tasks. One thing that we have to mention about procedure-oriented programming or POP is that data and functions are typically separate entities. What does this mean is that most programming languages like Python, they have built-in data structures such as lists, tuples that we're going to cover very soon, and you can build functions that they operate on these. But in this case, these two are two separate entities, and they really are not designed to work together. And that's something that in many cases, it causes issues with reusability. On the other hand, with object-oriented programming or OOP, which is the basis or backbone of machine learning and deep learning libraries, the goal is to organize the code into reusable and self-contained units called objects. And you can think of your program as a collection of interacting objects. When you're working with objects, you need to be familiar with uh, two things, attributes and methods. Attributes are kind of like the data that we just talked about, and methods are like functions. And the nice thing is that since you create these objects yourself, then you can really have these data and functions that they work together. Or we also call them encapsulated within objects. Just to dig a little bit deeper into this idea of object-oriented programming, I would like to emphasize that we have four things that we really need to know when we talk about object-oriented programming. The first thing is class. So what is a class? A class is a template for creating objects. You can think of class as a template or blueprint for creating houses with different numbers of bedrooms or different paint colors. Now, an object is an instance of a class, meaning that once you build a house with, let's say, 3 bedrooms, then this is an object because it's an instance of the class or the template that we have. So you see here the connection between class and object. Then the next thing that we need to know is that each object has two related things. One is a data and the other one is a function. The data part is what is known as attribute. You can think of attribute as property or characteristics of an object. For example, in this case of building houses, if we have a house with 3 bedrooms, a property of this house is the number of bedrooms, and in this case, that number is equal to 3. You can also have other properties or characteristics, such as the exterior color, interior color, a square footage, right? So these are all properties or characteristics. On the other hand, methods are basically functions that they operate on these attributes. And this is very helpful. Let's say that you have a house with 3 bedrooms, and now you want to add one more bedroom. So what this method can do is basically saying that I want to add 1 bedroom, or I want to change the exterior color of the house to change some of the properties or characteristics. So you can see that in this case, we really can encapsulate these attributes and methods to efficiently work with each other. And I would like to emphasize that attributes are basically variables and methods are functions because they are supposed to take some actions and change properties or create new properties in general. Throughout the rest of this lecture, we are going to see several examples of object-oriented programming, especially from the mathematical perspective, so that we understand how we can use this concept for reusable and versatile machine learning and deep learning tools. To get it started, let's start with the idea of data structures in Python. There are 3 main data structures that we use them very frequently in this course: lists, tuples, and dictionaries. And overall, data structures, if you're not familiar with this term, they are containers that organize or group data together so that you can have efficient storage, retrieval, and manipulation of information. This is an important task in programming because whenever you are working with some data, you want to make sure that you can efficiently store them and also you can access them when you want to retrieve this information. What is a list? A list is an order mutable, which means changeable collection of items. If you want to define a list in Python, the way that we do this is using square brackets. And then you can have as many items as you want and you separate them with these commas. So in this case, let's say we have this list, which we call it my list, and has 3 elements, 10, 20, 30. And we are looking at several things. We want to print this list. We want to see the type of this list and also the element with index 1. So if I run this cell, you can see that the list is 10, 20, 30. That's something that we expected. If you're wondering what this \n is, so this means new line. So I usually like to print each information in a separate line so we can understand what exactly we are looking at. So the second line is the type of this object or this list that we have here. And you can see that it says class. And remember, we just talked about class is the blueprint or template, and it says list. And this is because in Python, the main approach is object-oriented programming, meaning that anything that we have here, they're all objects. And you can see that this myList is an instance of a class called list. And that's why we call this a Python list. And soon we're going to see how you can create your own class or how you can modify classes, which is really interesting. And then the last thing we want to check here is that what is the element index 1? And that's something that might be surprising to you because you can see that the element with index 1 is actually the second element in this list. And that's because in Python, indexing starts with 0. So this means that this 10, if you want to retrieve this information, you should actually here choose 0. And you can see that this is the first element. And then the second element is index 1. And if you're looking for the third element, that's index 2. So that's something to always keep in mind. And the other thing is that, which is really interesting about Python, you can have negative indexing, meaning that if you want to choose elements from the end of the list, starting here, then you can use -1. That's the very last element in this list. You can use -2. So if this one is -1, then the next one from the end of the list is -2, which is 20. So you can use both positive and negative indices to retrieve information from a Python list. But right now, let's just put this back at 1. And if I run this cell, you can see that this is the second element, which is 20. This is how we define a list. But what about a tuple? A tuple is very similar to a list in the sense that it's an ordered collection of items. The only difference is that a tuple is not mutable, meaning that it's not changeable. And the way that you define this is using parentheses. You can see that here we have this tuple, which is 10, 20, 30. And in this case, we print this tuple, we look at the type, and again, the type is a class, and the name of this class is tuple. And you can look at each element you want. For example, the one with index 0 is the first element, and that's 10. But what's interesting here is that if I run this next cell, where I want to assign the value of value 3 to the third element, meaning that I want to replace this 30 to be 3, if I run this, I get this error message. It says type error. That's one type of error in Python. And the most important thing when you're working with Python is to actually read the message and see what it says. In this case, it says tuple object does not support item assignment. And that's exactly what we mentioned about tuples, that they are not mutable, meaning that once you define them, you cannot change their elements. So that might be something that is very helpful in some cases, because you want to make sure that nobody is changing the values that you have assigned to a collection of items. And in this case, tuples, using tuples is very helpful. So far, all the two data structures that we have seen, they are ordered collection of items. However, dictionaries are unordered collection of items. And you may wonder, well, then how we can retrieve information from dictionaries? And dictionaries, they use a different strategy, which is called key value pairs. So in this case, means that if you look at the way we define dictionaries using curly brackets, is that we have these keys, colon, values. So if you want to retrieve this information, value 1, you have to provide key 1. And the same thing for other values. So in this case, the advantage is that you don't have to memorize that, well, is the second element in that list that corresponds to this information or something else, right? Because then you have to always have somewhere else a table that summarizes what it is exactly included in the second element in the list. In this case, you can really make this simpler by just saying that, well, I have a student in my class. The name of the student is Jane. Age is 22. And major is mathematics, right? So right now, if I print this as student, which is a dictionary, and I can confirm this by typing type a student, you can see that it's a dictionary. And also, if I want to find the name of this student, I just put a student name, and now I see the name is Jane. You can also choose age, etc. So this is a different way of retrieving information where I don't have to provide indices. Instead, I provide these keys. And keys are in general strings or character strings, which are shown by these double quotes in Python. The next thing that we mentioned earlier was using functions in Python. How can we even define a function in Python? In order to define a function in Python, you use the keyword def for define, and then you choose your function name. And inside parentheses, you have your input parameters or arguments. So these are the inputs of your function. Obviously, you want to perform some operations on these inputs. That's what will be included in the function body. And then something that is very important to remember about functions and very easy to forget is that you usually need to use return to return the result of what you're doing in the function body. Otherwise, if you don't have this return, you call this function, you perform these operations, and you don't see any results because there's no return at the end of your function. So that's something to always keep in mind, that in general, when you define functions, you either want to use return or print, because in that case, at least you print something. But in many cases, we don't want to necessarily to print something immediately, and you want to store it somewhere else, and then obviously you can print it if you want. So that's why return is something that is more common. The other thing is that once you define your function, really there is no end function at any point here. So you need to let Python know what exactly is inside this function body that you have. And the way that we do this is using this indentation. So you can see that here, you put the colon, and in this case, you have typically 4 spaces between the beginning to where you have your function body. So this means that everything here is included inside this function definition, and everything else that starts at the beginning is outside of this. You can see this using like this function. So let's say we want to write a function called grid, and you just provide a name, and then you want to return this character string which says hello, and then whatever the input name is. In this case, you can see that if I press enter, I've already have the right indentation, but it is 1, 2, 3, 4 spaces. That's something to always keep in mind. So this means that everything that has this indentation, including this return line, belongs to this function definition, but this line is not part of the definition because it starts from the beginning. Okay, so let's go back again to this function. What we are doing here is that we are accepting one input argument, which is name, and then we want to return this character string which says hello and then the name. And if you're wondering what this F means here, so this is what is called as the F string, or the full name is formatted string literal, is a feature in Python that provides you a way to embed expressions inside in string literals using these curly braces. So what this means is that we don't want to exactly print name, but this name is a variable and has some values, and we want to print those. So this tells Python that look at where this name is defined, and whatever is inside that name, printed here. So you can see that here, if I type this and run this cell, then we get what we are looking for: hello and the name of the person. And the nice thing about this F string, or formatted string literal, that we're going to use a lot in this course, you can use for printing multiple variables. So let's say you want to print hello, my name is, and that's one variable, and I am some years old. And this is really depends on, these two really depend on what we have assigned before these to these variables, right? So you can think of this as being part of another function where you have to perform some operations to know exactly what name and age values are. So in this case, use this F string, you use these curly braces, and you put these variables here. So if I print this, now you can see that we get the right text. My name is Alice and I'm 30 years old. However, if for some reason I remove these curly braces, you can see that if I run this, it says my name is name and I'm 8 years old, because right now Python, it says that that's what I have to print, name, and doesn't really look for what actually is inside name. In order to let Python know that that's our intention, you need to put this inside these curly braces. And now if I run this, you can see that everything works very well. So we talk about using dictionaries to to provide information for a student, right? Name, age, major, etc. And then you may wonder, well, why do we even need to use object-oriented programming, right? This using key value pairs is really a good idea. It's very effective, and I can store a lot of information and operate on those. But in fact, this is only useful for small scale problems and has several disadvantages. For example, let's say you want to handle complex scenarios where you want to define multiple students, like maybe thousands of students at a university or a school, and you may even want to change the structure of this data, like adding a new field or new key that represents, let's say, the courses that each student has taken, and also other information such as a student ID, etc. And also, there are cases that we want to enforce certain rules. For example, the age of a person cannot be a negative number, right? So, just in case if there is a typo or something like that, we want to make sure that we do not create cases that they do not represent real values. And because of these reasons, object oriented programming is definitely a much better alternative to use just a built in data structure like a dictionary. And in order to motivate this, we're gonna start with by defining our own class. So let's look at a very simplified case here. We want to define a class, and remember, class is a blueprint or template. We are not really creating instances right now. We just want to let Python know what the general structure is. And the keyword that we use is class, and then the name of the class. So here we call it the student class. And the most important thing, and kind of like, difficult sometimes to understand when you define a class, is something called constructor. So in order to understand what this does, remember that when you define a class, this is just a template, right? So this means that you have not created an object or instance yet. So once you create or you intend to create that instance or object, you usually want to make sure that you don't have an empty object, right? You at least have some minimum information included inside that instance or object. And in order to do that, we use this constructor. And the way that you define your constructor is a function. That's why we use def. And then you use underscore underscore init underscore underscore. So the reason that we have these two underscores is that this is a special function that Python doesn't want you to, by mistake, define another function which has the same name. So that's why in the context of defining classes, there are certain functions that start with this underscore underscore. And these things are basically saying that this has a very special meaning. It's not just any function. It has a function that has certain properties. And in this case, when you define an object or instance of a class, what happens is that in the background, you always run this, even without directly calling this function. And then the other part about this, which is kind of mysterious, is using the term self. So obviously, this is something that you can use any name that you want. It's a very good programming practice to use the name self. And this refers to the object that is going to be created, because right now this is a template. We don't even know what the name of the object is that's going to be created, that will be created in the future. So in this case, we are saying that, well, I want to call that thing that will be available in the future self. And based on that, now you can define attributes or properties and characteristics of that object, and as well as methods or functions. So in this case, when we want to create an instance or object, we want to provide two information, the student ID and name. The way we do this is using this dot notation. Self.student ID, we assign a student ID to this, and then name to self.name. So this means that this object that will be created in the future will have two attributes or properties, the student ID and name. And you have to provide those two, otherwise you get an error message, because this is something that by default will be executed. And then you can add other methods or functions. Something simple that you can add, for example, let's say you want to have a method called display info. And in this case, use this F string that we just talked about to print the student ID and name. So remember, any method that you have, you need to have this self as the input, because otherwise this method here does not have access to those attributes or properties. So that's how we can transfer that information from one part of class to the other part by making sure that this self is the input to each and every method that we have. So let's run this. And remember, right now we do not have any objects. This is just the template. But now let's create objects or instances of this class. We use the name of the class. We provide the student ID. We provide the name. And once we create this, if I just now say print whatever this object is dot student ID and dot name, you can see that we get this information. But we have a much better way of presenting this data because we define this method called display info. And if I run this cell, you can see that we get this information that we have here. Something again to emphasize here is that when you, like, let's say call this method display info, you don't have to provide self anymore, right? Because that's just an internal process inside this class to make sure that you have access to these attributes and properties throughout the class. But once you want to use these methods, you always ignore or do not use self anymore. So you can see that now here we do not need to use the term self. But let's make this a little bit even more interesting, right? So we have this base class, which is a student and has a student ID and name information. But let's say that we want to add an attribute, which is called courses taken, which this keeps track of what courses each student has taken. And you can see that the way that we do this is that by adding this to our constructor, and in this case, because once we create an object for a student, at the beginning, probably the student does not have any, any prior courses. So in this case, we instantiate this as an empty list. That's what this means. Just this is an empty list. But then what's really interesting, we can add this method, which is called add courses, which is a function. And you can add the information about self. So we know what courses already have been taken. In this case, it starts with an empty list, but in general, you may have already have some information included. And then you get the names of new courses. And then you use this dot extend. And what this does is that it adds these courses that are provided here to this list of courses that they have already been taken by this student. Okay, so now you can see that. So this is the class. Everything here is indented, has these 4 spaces here. So this means that everything here is inside this class. Now we want to use this. That's why we go to the beginning of the line. And now we're gonna use the name of the class, provide the information for student ID and name. Remember, you do not have to provide courses taken at the beginning because we assume that it's just an empty list. And we display the information. So you can see that student ID, name, courses taken is an empty list. But the nice thing is that now we can add these courses, these 3 courses, mathematics, history, and programming. And if you run this cell, you can see that this information or these attributes, especially these courses taken, this one has been updated and now includes mathematics, history, and programming, whereas before was an empty list. And we do not have to provide this information about courses taken right away. We can do this gradually. So now this student one, if you look at courses taken, has these 3 courses included. Now we can add a new course, the statistics. So this case, to whatever is inside these courses taken, we are going to add or extend one more course, which is statistics. So if I run this cell, you can see that now we also have a statistics. So there are a total of 4 courses. So this is one of the nice advantages of using object-oriented programming, that you have a base class with certain attributes and certain functionality. And now if you want to make changes, you want to modify these, make this more suitable for your task or even more advanced, it's typically much more flexible than procedure-oriented programming that we discussed before. To recap what we just covered, the main way to define a class is that you use the keyword class, then the class name. You always want to have a constructor. This is very important because you don't want to have an object or an instance with nothing in it. You want to have at least some minimum information in it to distinguish between different objects or instances. Remember that we always use self. Self refers to the instance being created. Arguments are parameters passed during instance creation. And then you can have other methods. And each method should have access to self and possibly some other arguments. To make this more interesting, let's have a basic implementation of custom array class. So why do we need this? So we said that in Python, we have a built-in data structure called list, right? So right now, 1, 2, 3 is a list, 4, 5, 6 is a list. But what if we want to perform some mathematical operations? Let's say I want to find the dot product or inner product between these 2 vectors. Well, there's really no easy way to directly do this in Python unless if you write your own function. And then there is a problem because now if you have more complicated like operations, then you have to modify your entire code, and that's not really sustainable. So what I really want to do right now is to define a class that mimics some of the functionalities of a NumPy array, and that's something we're gonna cover in the next video. NumPy is this very powerful multidimensional array computation library, and we can focus on, let's say, a few functionalities here, like storing the length of each list or vector here, because we are thinking of, for example, these lists as like 3-dimensional vectors in the mathematical language. And then with some basic operations such as dot product or inner product or the vector norm or Euclidean norm. Well, in this case, we can definitely use some of the modules or libraries that are available in Python. One of them is this math module. So if you're looking for, let's say, implementing or finding the square root of a number, you don't have to implement that from scratch. That's something that you find in the math module. So that's really nice. And some other mathematical functions such as like exponentiation, etc. But the question is, if I have these 2 lists that I have here, how can I implement a dot product? So what is a dot product or inner product, and how we can find this if you want to break down into smaller pieces? So we know that in order to find inner product or dot product, we have to multiply corresponding elements from these 2 lists or vectors, meaning 1 and 4, and then multiply 2 and 5, 3 and 6, and then add all together. So how can we, if we have these 2 lists, how can we find these corresponding elements from these 2 lists? So in Python, there is a very nice way to do this, and that's what this zip function does. So if we provide these 2 lists to a zip function, creates a list of tuples. So right now, these parentheses, actually I'm referring to tuple in Python. So we have a mixture of math and Python here. So if you use zip, you get a list of these tuples. And now the next thing is to multiply these elements inside each tuple and then add them together, which you should be able to get 32. So let's implement this step by step. And to show you that how this works, so you can see that if I use zip and then list1 and list2 and convert this to a list, that's exactly what we get is a list of tuples, right? So it's a list because it has these square brackets, and this is a tuple because we have parentheses. Now, for each x and y inside each tuple, you want to multiply them and add all these results together. So that's exactly what this line is. That's the nice thing about Python because it's very easy even to read. We are saying that for each x and y in these tuples, multiply them together and then add all of them. And if I do so, I get that 32 that we just talked about. So the goal here is not to use procedural oriented programming, but I wanted to break down this into these simpler steps so you understand the next cell that we have. So if I ask you to write a class for this custom array that we have, the very first thing is to import the math module so that, for example, we have access to a square root and things like that. And then we define class custom array. We need to have a constructor. One thing that is nice, we can also make sure that the input that we get is valid in the sense that this input is actually a Python list. And Python has this function called isInstance. So what this checking is whether data, this input, is a Python list or not. If it is true, that means that data is a list. And if it's false, means that that's not ideal because we wanted a Python list. So if this is false, meaning that this is not a Python list input that we have, then we have a not here, so that would become true. This means that we now go inside this if statement and we raise this error, a type error, like that's, the error message similar to what we saw before, that says that this input must be a list. Okay, so in this case, we have a safeguard against inputs that are not Python lists. But what if it is a Python list? So in this case, we need to store this data as the attribute, that's this self.data. And then we also have to store the length of this list or the number of elements. In the previous case, we had 3 elements inside each list. So once you create this class, so you provide this information about the list that we have, and also the size of the list, the number of elements in it, or if you think of a vector as the dimensionality of the vector. Now we want to define our dot product or inner product. Remember that with dot product or inner product, we need to have 2 vectors. Again, the very first thing that we can check is to make sure that these 2 vectors have the same length. That's why that attribute, that dot n, is very important, because if the 2 vectors do not have the same length, there's no way we can find the dot product, and we should raise an error message. But if they do have the same length, the way that now we can compute this is by returning this sum of multiplication of corresponding elements. And here we also add one more functionality, and that's vector norm. And in this case, since we're using the Euclidean norm, the way that we can find this is the square root of the sum of the square of the elements, right? That's how you find the Euclidean norm of a vector. So for each element in that vector, we raise that to the power of 2. That's what this notation is here. We add them together and we take the square root. That's why we had to import math module. Otherwise, if you just say sqrt for square root, you get an error message that's not defined because it's not inside the main Python framework. So we're gonna run this cell to define this class. Now we are ready to create objects or instances of this class. We have array1, which has these 3 elements, and array2. Now we want to perform the dot product operation. In order to do that, use array1. And now remember that this method is called dot product. As I said earlier, we do not include self, so this means that you only need to include the name of the other array. And the other array that we want to find the inner product between them is array2. And for array1, we just want to find the vector norm, so you don't have to provide anything else here because we just have self. And this makes sense because for this one, finding the dot product, we need 2 arrays. But for the finding the vector norm, we only want to find the norm of 1 vector. And if you run this cell, you can see that the dot product is 32. And the vector norm is 3.74. So you see that this is working as expected. Something that we can also add here is let's check the type of this array1, which we know that it is coming from this custom array. So when we do that, you see that we get the type here, which is custom array, but you also notice that there is this thing called main here, underscore main, which again, anything, as I said, it starts with underscore means that it has a special meaning. So you can see that this is a little bit different than before when I used like type. Like when I earlier used type, for example, here, it says class list, but now it has this underscore main. And the reason for this is that in general, when we are working with classes or even like functions, we do not want to include all of them in one Python file or in one Jupyter notebook. We really want to create a nice way of organizing our code bases. And the way that we can do this is using a module. So what is a module? It's very easy to create that in Python. You just need to create a Python file, which has this .py. So .py is just a Python file. And then you give the name that you like. And then inside this Python file, you can see that now I just included the definition of this class, which is custom array, which keeps track of the length of the data or the number of elements in that vector, also some operations or methods such as dot product and vector norm. And once you create this Python file, now we can just say that from this Python file that we have, that's the name custom underscore array, import what we want to work with, so which is custom array. And in this case, now we can start using this class by creating objects and calling methods. And if you look at the type of this object, now you see that exactly we have the same structure as we had before. So again, this is like a small point here, but that's something like is a really good programming practice. And the reason is that in general, you may have like multiple classes, like that's how like machine learning and deep learning libraries are, right? So you may have different classes for different operations and different objects, and you don't want to include them inside each like Python file or Jupyter notebook you have. You want to have this utility file or this big module where you include all that information, and then you import things that you want to work with, right? So we may have like, let's say 5 different types of custom arrays, and depending on the task, we want to just import the one that we want to use. So we are not just importing everything or defining all classes that we may not even need some of them. So that's what a module is. It's basically a Python file with classes, functions, variables, etc. In there. Now, when we have these modules, we can have multiple of them, especially in a hierarchical model, to create what is known as a package. For example, NumPy that I've talked about it, and this is the link to this web page, is a package that contains various modules with different functionalities for working with numerical arrays. Inside NumPy, there is this linalg module, which includes linear algebra functions such as matrix multiplication, determinants, eigenvalue decomposition, etc. So that's like a whole bunch of things that are included in one module. And then we have another module for random numbers. So this includes things such as like random numbers and performing random sampling, etc. So you can see that this hierarchical model, which we can use or define using this dot notation, is very helpful. So we have the big package, and then we use dot to go inside these modules, and then you can use another dot to find what included inside that module. So this gives us a hierarchical model. Now that we know what a module is and what a package is, there's also something called library, which is a vague term in the sense that in general, library is a collection of modules and packages, right? So sometimes you may even have multiple packages together, and that is what is really called a library. But there is really like a thin line between a library and package, and in many cases you can call libraries also packages. But the most important thing here is that a module is a single Python file, which includes, definition of classes, functions, variables, and a package is a bunch of modules organized in a directory in a hierarchical way. Since we talk about NumPy, so you can see that we can import NumPy, and it's very common to use an alias. So here we use import NumPy as np. So similar to our custom array, inside NumPy, there's this thing called np.array, and this creates NumPy arrays. And NumPy arrays also have methods such as dot, and that's what we use for dot product. And as I said, we have a numerical linear algebra functions, and one of them is this np.linalg.norm. And in this case, we find the dot product and the norm, and they're exactly the same as what we had before. So what we did here is really like a small version of, or a tiny version of NumPy, but you can really see the connections here, right? So if you want to put this in the language of object-oriented programming, this means that once you call this np.array, you're creating these objects. Now we can perform operations with these objects. One of them is this dot, which is dot product. There's also other things such as this np.linalg.norm, which says that norm is part of the linear algebra module, and linear algebra module is part of the NumPy package, right? So you see the hierarchy here, and that's why it's important to understand the basics of object-oriented programming. To wrap up this lecture, let's do something a little bit more complicated. Let's plot the probability density function, or PDF, of the standard normal distribution. So we are working with numbers, so let's import NumPy as np. We want to plot something. Let's import matplotlib, which is for plotting and visualization. Also, since we want to work with probability density function, in this case, we can use another library which is called SciPy. And inside SciPy, there is a module called stats. So now you can see this again, like hierarchical order. And inside that, there is a class called norm. And this represents the normal or Gaussian probability distribution. Right. So that's like kind of like really important to understand like how these modules and packages, they interact with each other. And after this, we can, let's say you want to plot the values of the PDF for different like X values or different inputs. So what we do, let's say we want to plot the probability density function from -4 to 4. So we create 100 equally spaced points from -4 to 4. Then we instantiate this class, which is the norm class, with mean 0 and the standard deviation 1, because that's the definition of the standard normal distribution. And this class also comes with a method called .pdf, which calculates the PDF of a normal distribution. And this way you can find all the PDF values. So you can see that this plt.plot is very simple. You just provide X and Y values. So X are the inputs, -4 to 4, and we have the actual PDF values here. And the rest are some customization options that are very important, such as adding labels, X labels, Y labels, titles. These are very important whenever you plot something to make sure that everybody can see what you are doing. And you can see that that makes sense, right? So this is a normal distribution, the famous bell-shaped curve, and it gets very close to 0 as we go towards plus and negative infinity, and that's the PDF of the standard normal distribution. But let's say for some reason you don't want to use this norm class, or you don't know if it exists, and we can do this from scratch. Obviously, it takes a little bit more time and effort to do that. In this case, using our knowledge from probability and statistics, we know that if we have a normal distribution with mean 0 and a standard deviation 1, this is the formula for the PDF. So you can define your own function. So in this case, we are really now switching from object-oriented programming to procedural-oriented programming. And we can see that now, obviously, you have to do more on your own because you have to implement everything. And we return exactly what we have here. 1 over the square root of 2 pi. Math.pi is the pi. And then the exponential of -0.5 times x raised to the power of 2. At least that's a nice thing about Python. It's very easy to read code. And with that, I'm gonna plot the values that we had before. The PDF values were like what we calculated before using the norm class. And this RPDF is what we get based on our own function. And I just want to make sure that these two are actually consistent. So if you run this, you see that unfortunately we get an error message. And I knew this because I already included how we should fix this problem. And the reason I included also this is to make sure that whenever you get an error message, it's very important to look at the error that you get. So here is basically very easy to understand what the error is. It expects this function that we have here, length 1 arrays, but here we are providing this X array, which is created using NumPy, and this has 100 elements in it, right? Because it's elements from -4 to 4. So this is saying that, well, I expected a single number, but I've been given 100 numbers and I cannot deal with that. And that's why we really need NumPy throughout this course, because that's what's really useful when you have multidimensional and large arrays. So if you want to fix this, there are multiple ways to do this, right? So one approach is to give these values of X one by one. So in this case, we can, for example, say for each value or item in X, let's just call this item, because X has all those 100 elements, calculate the value of this RPDF at that point. So in this case, item is going to be a single number. And you can see that this red one is the new PDF that we calculated from scratch, and it matches perfectly. So that's one way to solve this. The other way to solve this is instead of using math.square root math However, we just use NumPy built-in functions. In that case, because NumPy is designed to handle multidimensional arrays, we do not have to use this for loop anymore. But for now, I'll stop at this point because we're going to cover NumPy in more details in the next video. And if you're interested in learning more about some of the topics we covered here, such as like the for loops, if statements, even more examples with object-oriented programming, what we have here is a summary of the first 9 lectures in programming for data science. And I have both Jupyter notebooks and YouTube videos on my GitHub page. So please, if that's something that you think that you need a little bit more practice, make sure to look at these Jupyter notebooks. But my goal here was to provide a brief summary of everything included there in this lecture. Thanks for watching.